All right, subscribers, welcome back to another episode of Science with Surbeck. Today what we're going to be doing is some extra combined gas law problems and also doing some problems with Avogadro's principle. So I'm going to do problems 1 and 4 and then expect you to do the remaining problems of this worksheet. All right, so we start out with number 1. It says hydrogen gas is at a temperature of 22 degrees Celsius and is confined to a 5.00 liter cylinder which exerts a pressure of 4.20 atmospheres. If the gas is released into a 10-liter reaction vessel at a temperature of 33.6 degrees Celsius, what will the pressure be inside the reaction vessel? So we need to start out here with what formula do we use for the combined gas law. Remember, our P1 times our V1 divided by our T1 is equal to our P2 times our V2 divided by our T2. So let's go ahead. We're just going to plug in numbers here to be associated with these values. So I'm going to list these out as P1, V1, and T1. Okay, so it says initially here, if we read this top part here, initially that pressure is 4.20 atmospheres. So we have 4.20 atmospheres as our P1. Our V1, our first volume, is 5.00 liters. So we write down 5.00 liters. And then our T1 is at an initial temperature here of 22.0 degrees Celsius. So 22.0 degrees Celsius. Remember, we cannot have temperature in degrees Celsius, so we need to add 273.15 to this number. Okay, so we'll get out our calculators and add that together. All right, so adding this together, 22.0 plus 273.15, we press enter, we get a Kelvin temperature of 295.15 Kelvin. Again, your temperature, you have to use Kelvin. Now, we're going to do the same thing for our second values here. So our P2, V2, and our T2. So in our problem, it says, hey, what will the pressure be? So our P2 is ultimately our question mark. Now, our V2, it says the gas is expanded into this 10-liter container. So our V2 is 10.0 liters. And then our temperature is increased to 33.6 degrees Celsius. Now it's in degrees Celsius. We can't have that, so we need to add 273.15 to get in that Kelvin temperature scale. Okay, so we turn to our calculators, 33.6 plus 273.15. We press enter, and we get a second temperature of 306.75 Kelvin. Okay, so now we have all the players in the game, and we can solve for P2. So I'm just going to plug all of these values back into this formula that we have here. So we are going to take 4.20 atmospheres times our volume number 1, which is 5.00 liters. This is all going to get divided by our temperature in Kelvin, which is 298.15 Kelvin. And this is going to be equal to our P2, which we don't know, we're trying to solve for, times our V2, which is 10.0 liters, all divided by our second temperature in Kelvin, so 306.75 Kelvin. Okay, so now we need to be really careful with our algebra here. Remember, we have quote-unquote equivalent fractions, so we are going to cross multiply. So what I'm going to do in my calculator is I'm going to take 4.20 times 5 times 306.75. So 4.20 times 5.00 times 306.75. I press enter. I'm just going to write all of this down. So we have 6,441.75. And that would be in the units of atmospheres, liter, Kelvin. Okay, then what I'm going to do is I'm going to cross multiply my other business here. So I'm going to take P2 times 10 times 298.15. So on my calculator, I'm going to take 10.0 times 298.15. I press enter, and I get a value of 2,981.5. So this is 2,981.5 times RP2, and this is units of liter Kelvin times P2. Now, because P2 is attached via multiplication, we need to divide each side by 2,981.5 liter Kelvin. Okay, so each side needs to be divided by 2,981.5 liter Kelvin. Okay, so what I'm going to do in my calculator, is this. I'm going to take 6,441.75 atmosphere liter Kelvin divided by 2,981.5 liter Kelvin. So again, 6,441.75 divided by 2,981.5. I pressed enter, and I get a value of 2.16, and that would be 2.16 atmospheres. So our second pressure here, I'm going to write this above, would be 2.16 atmospheres. And that would be our second pressure. Okay, so again, be careful with your algebra here, but it's no different than the gas laws. We just put all of those variables together here. All right, so I'm going to show you number 4, and then we'll be good to go, or you'll need to do the remaining problems. So it says, how many moles are in a 6.06 liter tire at STP? Well, remember, STP, I'm not going to write this down, but is 25 degrees Celsius and a pressure of 1 atmosphere. And at STP, at exactly STP here, 1 liter of gas is equal to, 1 mole of gas. 1 mole of gas is equal to 22.4 liters. Now, we're going to use that here in just a second because we have 6.06 liters. So we set this up like a stoichiometry problem where we have 6.06 liters, and we set up that conversion. So we cross cancel diagonal. We have liters that will cancel on the bottom, and we're trying to get to moles on top. Well, lucky for us, we have a nice conversion. So the number in front of moles is 1, and the number in front of liters is 22.4. So we put 22.4 liters of our gas. Okay, so all we need to do here is take 6.06 times 1 divided by 22.4. So 6.06 times 1 divided by 22.4, and we get a value to 3 significant digits here of 0.271. So this would be 0.271 moles of gas. And that would become our answer. All right, so you need to do problems 2 and 3 as well as problems 5, 6, and 7. 5, 6, and 7 on the other sheet of paper. I hope you have enjoyed this episode, and as always, if you haven't done so already, make sure you subscribe.